Hello everyone, this is Kolli and today we are building this. This is a fader board that sends MIDI messages to your DAW, and you can use these three physical faders to control any parameter in your DAW, which is a very good news because as a mix engineer I tend to draw a lot of automations in my mixes, and I love to use something like this to draw in my automation, which feels more physical and makes me feel more connected. Even when I'm playing my virtual instruments, I'm playing my orchestral plugins, I tend to use these faders a lot to control my expressions, my dynamics, and my performance. So this is a very easy project. This takes a very less amount of time to build, I would say, and only have a few components in it, only these faders and a microcontroller that I'm using and this universal PCB that I'm using to connect everything together. You can easily get this component in any local market, even online. They are very easily available and very cheap to build something like this. Now this is not put in an enclosure, but if you do that, this will look as good as it gets and also work very nicely. So I hope you like the video, and if you want to build alongside me, it's very easy. Everything you need is given in the description box below to build something like this. So yeah, see you.
Let's talk a little about the brain of our computer. Raspberry Pico is a very powerful chip that offers native USB support. Now, this has a lot of pins in it, but we will be only focusing on the ground pin, which is the third pin from the top, then the 3V3 pin, and the analog inputs of the Raspberry Pico, which are GP28, GP27 and GP26 for A2, A1 and A0. Now remember, it is important to use 3V3, not the 5V, as the analog inputs are supposed to be for 3V3. Let's talk a little about the potentiometers. You really want to get the type B10K potentiometers, as that is the sweet spot for this project. Now these are stereo potentiometers. They have two channels, one left, one right. But I will be using only one channel from each of the potentiometers. Meaning, if I use these two, I will use this as my ground. Pin number 1 is going to the 3V3, pin number 2 is the whipper that is going to the analog input, and pin number 3 is going to the ground. My sliding potentiometers are stereo in nature, meaning they have two channels. Let's consider one to be left, one to be right. And for the time being, I will use only one channel from each of the sliding potentiometer. Let's say I am using the right channels of each sliding potentiometer. Then I will connect the lug number 3 on the right to the ground pin of the Pico, lug number 1 to the 3V3 pin on the Pico, and lug number 2 will go to an analog input. Now to connect all of them together, as you can see, I have daisy chained all the grounds of my sliding potentiometer, meaning all the right channels from all the three potentiometers are combined to each other and then going to the ground. Same goes to lug number 1 in each of the sliding potentiometer, which are connected to each other and then going to the 3V3 input on the Raspberry Pico. Now finally, the whipper or the lug number 2 on each of the sliding potentiometer are going to different analog inputs of the Raspberry Pi Pico. For example, 1 to 28, number 2 to 27 and number 3 to 26. And this is how we are going to connect all of our components together. For more details, you can check out the document that I have given in the link below to get a better idea on how to connect. A little bit of soldering later, we have this. Now in this, as shown in the diagram, I have connected all the ground pins or lug number 3 of my potentiometers to one cable which is coming out as this black cable. Now again, all the right lugs, meaning lug number 1, are connected to each other, which is then coming out as this red wire, which will then go to the Pico's 3v3. And finally, we have these 3 different colored wires, each coming out from lug number 2, which is the weeper of the potentiometer, which will go to each input separately. Now we need to download 2 major files, UF2 circuit Python for Raspberry Pico, and then a bundle of libraries which contains a very important library. Now I'm using Circuit Python version 10, therefore I'm downloading version 10 for the bundle. After you have both the file downloaded, get it to your desktop and get ready for the next steps. To connect our Pico to our computer, let's carefully pick it up and connect it to a micro USB to USB type A cable, which allows for data transfer. Now after connecting, you need to press that white button. While pressing that button down, you need to take the USB side and plug it in your computer, which will open a screen like this. Now this shows that your Raspberry Pi has opened up successfully in your computer, and now you're ready to install CircuitPython in it. Now to prepare the Pico, you get the UF2 file, just drag it and drop it in the Pico. This will automatically copy, install and reboot your Pico and open again in your computer. Now your Pico will understand your Python code. As you can see, the Pico has rebooted. Now there is one more step we need to do before uploading our code, that is, go to this zip file and find the MIDI library for our Pico. Once you spot the library, go back to our Pico, go to the lib folder, then just drag and drop the MIDI library from your archive to your Raspberry Pico, and this will automatically extract and make a copy of this file in your Pico. Once this is done, your Pico is prepared for us to upload our code in it. You will get the code for your Pico in my description as well. Just download the file, copy everything in it, and then go to your Raspberry Pico, go to the code file, open it with a text editor or any IDE, delete everything inside it and paste whatever you have copied from the code. Save it, and now your Pico is ready. Your device will see your Pico as a MIDI device. To test it, let's open a DAW. Let's go to add MIDI device section of your DAW, and let's see if it recognizes. Yep, it recognizes our Pico as a MIDI input device. Now let's name it something. And now Let's open a plugin and test whether our Pico are sending correct MIDI messages to our DAW. In my case, I have opened Analog Lab just to check whether my messages are being received correctly. As soon as I tap the MIDI learn button, as you can see, we have programmed the Pico for a 3-fader MIDI controller. Therefore, we have these 3 knobs here. Now to test it, let's get a jumper cable. I'm connecting one end of the jumper cable to the 3v3, and I will use the other side of the jumper cable to touch any of the analog inputs of my Raspberry Pico. If I, let's say, touch an analog input, yup, the controls are working fine. All 3 of them are sending MIDI messages correctly to my DAW. Now let's connect the Pico with the faders like I have shown in the diagram, and everything should work perfectly. After connecting all the components together, I have just simply reconnected the Pico with a USB cable to my computer and have mapped 3 of my faders to 3 of the faders in my DAW. As you can see, when I move one of my faders, the fader in the DAW also moves.
Hope you enjoyed the video. I hope you liked seeing me build this. Now, if you want me to add more feature in this, like if you want me to add buttons to store preset banks, write comment below. I was also thinking to build a web-based interface for this. If you want me to do that, you can also leave some comment below, and you will have all the files you need to build this in the description. So see you in the next video. Hope you have a lot of fun building something like this. Put it in an enclosure and this will look as professional and as good as it gets and work as smoothly as it can. So enjoy building this.